Hello friends, in this video I'd like to solve the following problem from the Romanian District Mathematical Olympiad for 9th graders 2011, problem number 1. On the sides AB, BC, CD and DA of a parallelogram ABCD, points K, L, M and N are chosen in such a way that vector KL plus vector NM equals vector AC. We wish to show that vector LM plus vector Kn equals vector Bd. So here are my hints for this problem. I think that it may be quite challenging for 9th graders, but here it is. First, make a good drawing, of course. Then, express KL and NM and AC in terms of vectors which are parallel to the sides of our parallelogram. So, for example, in terms of AK, KB, and so on. And crucial observation, show that vector AK equals vector DM and vector AN equals vector BL. And that should be it. So give this problem a try and I will see you in a minute. Alright, so I have made my drawing and I will take our assumption that K plus KL plus NM equals AC. I will take this equation, and now let's take a look. What is KL? To get from K to L, we can first go from K to B, and then from B to L. It's the same. NM, what is NM? Well, we can first go from N to D, and from D to M. And what about AC? Well, AC can be written as AB plus AD, because the addition of vectors obey the parallelogram rule. Alright, so let's leave the left-hand side as it is for now. And on the right-hand side we have AB. But notice that AB can be written as AK plus KB. AK plus KB. And what about AD? AD can be written as AN plus ND. And now we have some cancellations, namely KB disappears, ND disappears, and now, crucially, I will write it in the following way. I will leave BL on the left-hand side, I will leave BL, and I will write minus AN, and here I will put everything else, so AK minus DM. Alright. Now, this equation is very important, because notice the direction of this vector. We are taking BL is in this direction, and we are subtracting AN. So we are subtracting this vector. So the general direction of this vector is like that. What about the vector on the right-hand side? AK minus DM. Well, AK is this vector, minus DM is this vector. So this vector is like that. But remember that these two vectors should be equal. The only possibility for these two vectors to be equal is that they both must be zero vectors. So BL minus AN must be a zero vector, and moreover AK minus DM must also be a zero vector, which means that BL equals AN and DM equals AK. It's the only possibility. Alright, now let's take our drawing once again. And let's see what does it mean. Well, this means really BL and AN. BL and AN. These vectors, now we know they are the same. Which means, of course, that these two vectors are also the same. So it is already implied that LC is the same as ND, and moreover, AK equals DM. These two vectors are the same, so these two vectors must be the same as well. So KB equals MC. All right. Now let's tackle the sum of these two vectors, Kn plus Lm. We wish to show that this equals vector BD. So let's write it. What is Kn? Kn can be written as Ka plus An. And what is Lm? Lm can be written as Lc plus Cm. Very well, but now notice that Ka, this vector, Ka, and we have plus Cm. Ka can be replaced by dm, or we can write it in the following. Maybe let's write it in the following way. We have dm plus cm. And what about an? Well, let's leave an as it is. And what is lc? lc is the same as nd. Very well. And now let's notice what is cm plus dm. It's cd. And what is an plus nd? It's ad. cd plus ad. cd, this vector, plus ad, this vector. Maybe let's also write finally, we'll notice that cd is the same as ba. The same as ba. ba plus ad. ba plus ad is of course bd. And this is exactly what we wanted to demonstrate. And this closes the proof. So the most crucial part of this whole reasoning was noticing that these two vectors, which should be the same, are in different directions, so they both must be zero vectors. And that is it. So thank you very much for watching. I hope that you've learned something new this time, and I will see you next time. Goodbye.